Hello, this is Module 4, Investigation 3, and we're going to learn about one unit growth and decay factors and percent change and initial values. So when you take a look for the chessboard here, and then there are 1, 2, 3, 4, 5, 6, 7, 8 rows. And then there are the 1, 2, 3, 4, 5, 6, 7, 8 columns. So total squares, as you see, is gonna be the 64. Okay, so let's take a look. So number one, how large do numbers become if you repeatedly double them? Imagine you have a chessboard and place 2 pennies on the first square and doubles that to 4 pennies on the second square and double that to 8 pennies on the third square. So which means you have 2 pennies here, 4 pennies here, 8 pennies here, which is doubles of 8 is 16, right? So next one should be the 32, right? And 64, right? Yeah, so keep working. So you putting the doubles and doubles for the next one from the previous. So A, there are 40 squares on the chessboard. Without doing any calculation, make 2 predictions. So number one, about how many pennies you think there will be the last square. It'll be matched to something you like the number of the students in your university or population of the Los Angeles and the population of the United States. So the number's getting bigger and bigger, right? So it's getting a double. So I don't know what you think. Okay, so I want you to choose from the students number of the students in your university or Los Angeles or the United States. For me is I think I want to choose the United States population. Okay, and then number two, how tall will the stack of the penny be on the 64 squares? As tall as a house, as tall as a skyscraper, and the height of the Everest, and something else. Well, let's see. I think I want to be I'm just gonna to guess this Mount Everest. Okay, so we'll see. All right. So B, fill in the given table and use it to create the formula graph relating the number of the pennies on the square with the square population. Position numbers. Be sure to label the axis. Okay. So the first square, of course, there's a 2 pennies. Second square is a 4, 8, and then 16, right? And then, so how do you know how many pennies will be in the 10th square, right? So in here, I need you to actually think about the number change, okay? So 2, 4, but 4, I know there's 2 times 2, isn't it? And the 8 is a 2 times 2 times 2, right? And the 6 is a 2 times 2 times 2 times 2, right? Which is 4. So yeah, so this is the kind of patterns you'll see. So square number becomes the exponents of each of the base 2, right? So you can say this is going to be 2 to the 10th. So 2 to the 10th will be 1024 if you use a calculator. And then it becomes 2 to the 30th, which is 30th place, you'll get this amount of the numbers. So, okay, 741,824, which means it's going to be the 1,073,741,824. Okay, and then if I grab this, okay, so the axis is going to be the number of the square number, and then on the vertical axis I want to say number of the pennies. So number of the square, so I'm going to actually the jumps by the jump by the 10, right? So 10, 20, 30, 40, 50, and 60, because we have up to go to 64, right? Okay, so on the vertical side, it's going to be exponential. So I want to say at the beginning it's very small, but I want to say that maybe I don't know which is the best. Okay, so let me say maybe 1,000, 2,000, 3,000, 4,000, 5,000. I don't know. That's a big enough. 6,000 and 7,000. Maybe not a big enough. Okay. So when you have first place must be the 0. Actually, the exponent is going to be the 1. And then 10 pennies about the 10,024. And then 20 pennies, the number of the 20th place is how many squares? So the 2 to the 20th power, which is already the, what? That's so big, right? So it's hard to reach, right? So yeah, it's already been something like this, okay? All right, so and then the formula that I already showed to you, getting a number of the penny. So number of the penny, which is let n be the square number, and then let p be the number of pennies, and I can say p is gonna be the 2 to the nth power, right? So see, how do the numbers of the penny on the chessboard vary as you move along the board? For example, each time square position increase by 1. So increase by 1 means you go to the first to the next and next and next, okay? So it makes it doubles, right? So the number of the penny doubles. And then each time the square position increases by 2, which means you're skipping by 1. Okay, so from the 2, go to 8, go to the 32, go to the next one. Okay, so it becomes like a 2 goes 8, which is a 4 times, right? So it's gonna be the number of the penny. The number of the penny is actually the quadruple. Okay, so this is actually double means 2 times, which means 4 times. And then each time the square position increases by 3, which means from the 2, you jump to the 16. You jump to the 16, and then you just skip 2 and go to the next one. Okay, so 1, 2, and 3 like this. Okay, so this time the number of the penny by 3 means octuples, which means 8 times. So D, what is the percent change in the number of the penny square when the position is increased by 1? So with this case is when the square position increased by 1, the percent change in the number of the pennies is 100%. Because number increased by 2, 4, 8, 16, so on, right? So next square, you got 2 and another 2, right? So that 2 is from the previous, right? But this 2 is increasement. So that's exactly same one as this is exactly the same one as the previous one, right? So it's going to be the 100%, okay? Same as 8 too. 8 is 4 plus 4. So 4 is coming from the previous one, but next 4 is the same as the previous one, which is 100%, okay? So this is a 100% increase. Now the E, how many pennies will be squared on the square of 64? So it becomes a 264. So when you are writing it, it's going to be using the Sati notation. So about 8.45 times the 10 to the 19th. Okay, all right. Now I need to go to the number 6. Okay. Now in number 6, I want to compare with the some of your classmates made the following claim that the function of f of x equal to x squared and the g of x cubed are the sum of the other example for the exponential functions. So the difference figure from the exponential function to this function given is exponential function looks like this. This is the forms of the exponential. For the g of x, you should get to the 3 to the x power. So when you see the variable into the exponential exponents, and then that functions be called the exponential functions. So A, are your classmates correct? I want to say no because X is not exponent place, okay? Justify your answer using the you learned so far in this module. Because of the exponential function means the variable should be in exponent place. And then B, if you agree with your classmate would come up with at least 2 more examples of the exponential functions, you disagree with the classmates and they give you the possible reason for why this might be the common mistakes for the students. Because when we have exponential functions, actually it grows this way, okay? So same as that one too, but you can kind of see the difference between here. So let's say when you have x and x squared, then that's the difference between the 2 to the x power, okay? So x is a 0, 0 squared is a 0, but 2 to the 0 power is 1. And 1 squared equal to 1, but 2 to the first power is 2. And 2 squared is a 4, but this one come out the same, isn't it? But 3 squared is a 9, now 2 to the 3 is 8. So a little bit smaller this time, right? And the 4 squared is just the 16, but 2 to the 4th already 16. Oh, that's a come out same, right? And then 5 squared is a 25, but 2 to the 5th become 32. So now from the 5 and then the number going to the bigger as in the y value, okay? Then you can go to 6 squared equal to 36, but 2 to the 6 equal to 64. See that? Oh, already the twice, isn't it? And then 7 squared is a 49, but 2 to the 7 is, so 128. See the difference, okay? So getting more and more difference, okay? So when you say this is the x squared functions, and then for the 2 to the x power becomes kind of this, okay? So this is a 2 to the x power, okay? Alrighty. So let's take a look at the 7, okay? 7 was not a part of the problem that I should do, but I think I'm gonna show this one. So first of all, find the ratio of the output value that the corresponds increases of 1 input value. This value is the 1 unit growth factor. So the 1 unit growth factor means x is increased by 1. Did you notice, isn't it? X is increased by 1, right? So when x is increased by 1, so in order to find the ratio output value means you need to divide from the next one to the previous, okay? So divide by 4 over 16 or 1 over 4 over 0 0.25 over 1. So you get the same thing, okay? So I want to say 4 over 16, which is 1/4. So this is the ratio of the outputs, okay? Which is come out as 0 0.25. And then B, determine the 1 unit percent change by the comparison of the change in the output value up to the function value at the beginning of the 1 unit interval for x. So first of all, I need you to change to the percentage. So this is about the 5%, but this is 25% off, right? Not adding it, right? So what you need to do is, in order to find because the y value is decreasing, right? So what you do is always whatever percent you got, and then you subtract the 100%, which is whatever remainder, that's a percent change. So decreasing by 65, but 25% still stays. And then in order to identify the value of the function when x equal to 0, so but we already have an x value is a 0 here, you can just use a 16. So f of 0, it becomes 16. And then D, use information from part A through C to define the formula. So the formula for the exponential function is, I said, A times B to the x power, right? Yeah. So A is the initial value, and then B is the remaining rate, right? So f of x, initial is 16 times of, and then staying the limit, okay, staying rate, which is this is the staying rate, okay? So I put the 0 0.25, which is a 1/4 to the x power. You can also say 16 out of 0 0.25 to the x power 2. Either way is fine. Alright, for the 9, okay, so it's the graph is kind of breaking, okay? So you need to see that this is a kind of the cross, okay? The continuous. So this is increasing. So in order to find it is okay. So there's a 1 unit growth factor we found it. So 1 and 1, right? So you need to use 76.8 and divide by 48, which is 1.6. And then B is percent change, right? So this is increasing, so change the fraction, the percent, so 160. So 160 subtract 100, it's going to be 60% increase from the previous. And then f of 0, of course we can kind of find it, but this is a place of f of 0, right? But it looks like a half, which is it could be a 30, but I don't want to guess, so I'm gonna use a percent, the bean increase. Okay, so 1.6. So what I'm gonna do is I'm gonna do the number that we have in the when x equal to 1, so 48, and then I'm gonna divide by 1.6. I'll get 30. So now f of 0 equal to the 30. Because of that, now we are ready to write down the function. So f of x equals a is a 30 of the increase growth rate is 1.6 to the x power. And that's all. Okay, so that's for the module 4 investigation 3. Thank you for listening.